Okay. So this afternoon you're going to learn, or morning, you're going to learn about subgraph and trees. Okay, so this is 5.1.3. So just to refresh, all right, so we already done, identify 5.1.1, and then directed graph, weighted graph. So today we're going to learn about 5.1.3. Okay, and then these two will be problem solving. So 5.1.4 and 5.1.5 is for problem solving. So let's see what is subgraph and tree. So yesterday I gave these examples. So maybe some of you did not see the WhatsApp. So here is there's some correction. So Bao is B actually, okay, and Kuching is K, and Kota Sentosa is S. So, and then there's a pair of vertices also wrong. KP, this is SP and PR. So already send it to your WhatsApp group, right? And then just want to comment about your graph that you drew. Most I think 4 or 5 students send me your graph for me to go through whether it's true correct or not. So my comment is that when you drew a graph, network graph, okay, so let's say you have vertices, right? So okay, so this is vertices, and this is H, and then you have this another vertices, vertex, and then 2 edges. So maybe you put an A here. Okay, let's say here A, B, C, and D. So you found out that AD is a H also, all right? So AD, A connected to D. So you draw like that. Okay, so that's why I said if you use pencil to draw, right? If you draw with pencil, later on you can see, oh, now I have this overlapping. This AD is overlapping BC. So maybe I will be confused that, okay, between BC and AD, there is a vertex here. So you'll be confused. So that's why you use pencil to draw, then you can rub off and then you redraw a better network graph, right? So please don't overlap so much. Okay, maybe another one will be E here, right? So and B and E also is a connection. Therefore, you can see here there's a overlapping here, AD overlapping BE and CB. So you may be confused by your own drawing, and also when you present to others, it will confuse others also on whether this vertices between here, these 2 points here. Okay, so the purpose you use mathematics to solve problem is mathematics is is a simplified for you to solve problem, right? Not to make it more complex. When you see this type of question, let's say I give to, let's say you show it to your parents, you will be more confusing when you see this, why this one overlapping, right? So please, so this one you can change this diagram to more, more understanding network graph. Okay, there's a AB, right? So this one is C. Okay, this one is E. Okay, you have to redraw like that. Then it will, okay, now you will see clearly, right? That, okay, A, B, B, C, B, C, B, E, and AD, not overlapping. Then you can see quite clear. Rather than you use this diagram, it will be very confusing, right? So don't make the reader confused or yourself confused after that. All right, so let's go for subgraph and trees. So what are subgraph? So you see sub, Okay, still remember this word, subset. Okay, what do you mean? What you will remember if you can refresh back? Subset. So if I have subset, okay, one set, the set of A, we have 1 and 2. So here you can find out the number of subset, right? The number of subsets, that is 2 to the power 2, there are 4. But for graph, there's a similarity here, but you cannot find out how many subgraph there. Okay, you can find out if you want. So, but it's different from subset, right? But how you calculate the number of subsets. So you don't worry. The question will ask you to find out the number of subgraphs for a certain graph, right? So it just asks you to identify the graph, subgraph. Okay. So what do you mean by subgraph? Very simple. You just follow the 3 criteria, A, B, and C. So basically, the subgraph will be the subset for subgraph. Let's say I said subset, subset for the graph given, right? Then that means, okay, now you see, okay, and then the age must be the sub edges for the graph given, and then the vertex pace of age of G and the age must be the same, must be exactly the same. That is called subgraph, right? So let's see this example. So determine whether the diagram 1, 2, 3, 4 are the subgraph of G. State your reason. Okay, you see this is the graph given, graph G. So you see diagram 1. Okay, diagram 1. So P and S is connected with E5, right? E5. So let's see. So here is E5. So you see, is it exactly the same? So this is exactly the same. Therefore, this is a subgraph. Okay, so now we go to the next one, diagram 2. So diagram 2, I use a different one. So you can see here PQ, okay, PQS, the relation PQ. So P with a loop E2. So you see here, all right, you see there is no loop here. Now you check here. The loop is in Q. So therefore, this is not a subgraph. So what is the reason? So the subgraph will be, it's not a subgraph. Why? Because the loop E2 is at vertex Q, right? That is one of the reason. Because E1, E5 is correct. Only the E2 is not in the position, right? It should be on Q, the loop, but the diagram show is the loop is on P2, right? So there is a reason. Then we go to another one. Okay, P, right? This is also a subgraph or not? Okay, let's say you check. Okay, this is E3. You see here is E3. So maybe the wording is quite small, right? If I put bigger. Okay, you can see here, this is E3, this is E5, and then this is E2, correct? This is correct, huh? You see, here is correct, but this is wrong. So this is not a subgraph. It's not a subgraph, sorry. It is not a subgraph. Because E3 is not the edge of P and S. Okay, so that's your reason. Then diagram 4, you check diagram 4. See PQ, E3, okay, E2, E4. So you can see here E5 correct, E4 correct, S, R, P, Q, all correct, right? And then E1 correct. Only these two are terbalik. Okay, terbalik. Therefore, it is not a subgraph. Okay. a subgraph. Okay, why? I think you can give the reason. Okay, you can also you can this is the book textbook example, so you can go to the textbook there and read further what is the reason given in the textbook. So maybe I go, okay, it's on page 139. So diagram 4, no, because the loop and the edge connecting Q and R are wrong. Okay, so for diagram 2, no, because the position of loop E2 is not on vertex Q. All right, no, because diagram 3, no, because the edge connecting P and S is not E3. All right, so there's what I write is almost the same, so it's not technical. Okay, so remember subgraph is everything exactly the same, right? Must be the same. If you have a dot, also is considered a subgraph. Huh? A dot also considered a subgraph. If I draw Q like that, it's a subgraph. All right, so I draw an S, also a subgraph, because this S and Q is a point, a vertex or vertices on the graph, right? So that is a subgraph, right? Okay, now we go to example 10. Okay, so this one you can try to do by your own. Okay, determine whether the three subgraph determine, sorry, this is not determine. Huh? So you change this one is to draw, right? Draw three subgraph of each graph. Okay, so maybe the first one you want to be play safe, so you just draw P and Q, E1. And then the second one you want to be safe. Okay, you just draw P, Q, and you just copy exactly the same. Right? Then the last one will be connecting the 3 points, okay, or the 3 vertices. So P, Q, R. Then you just write down everything given. So if this is 1, 2, 3, of course this is correct, right? So play safe better, okay? And then one more thing is don't be clever enough just to, let's say, okay, now I just want to be clever. I just write P, Q, and R. So is this correct or not? So this is wrong because your E1, E2, E3 is not listed, right? So determine, draw 3 more graph. Okay, so for P, that's why I said you play safe is good enough. So you just do one PQ, okay? Or you draw another one, this number 1. Number 2, you can draw like that. Okay, so this is S. So remember to label it, label E5, and then E3, then this is R, this is P, okay? So list down everything. Then the third one, maybe you just follow exactly. This is your third graph, right? So that's how you do it. Okay, represent information in the form of networks. Okay. I think the labeling is wrong. Huh? Never mind. Okay. So what is tree? Subgraph is one part of the graph, right? So one part of exactly one part of the graph. So what is tree then? Right, tree. So tree will be very technical. Tree, huh? So you have to follow three very important notes here. 1, 2, 3. Simple graph. It is a simple graph. Okay. The first condition must be a simple graph. You see a loop, that is not a tree, right? All vertices are connected, and each pair is connected only once with one, only with one edge. Okay, I think my let's see. Okay, only one edge, so not once. Okay, can you do your correction? One edge. and then the number of edges must be less 1 from the vertices. That means if I have a vertices of 8, then my edge must be 7. Okay, if my number of vertices is 5, then the number of edge is 4. This is very logic. So let's say I give you, we do some, we call it deductive, inductive, say inductive. So I have 3 dots, right? A, B, and C. So it will be connected only with one. That means one vertex, one pair is only one vertices. One pair of vertices is only one edge, right? So therefore you can see here there are 3 vertices and the edge must be less to 1. That means 2 only. If I have A, B, C, A, B, C, sorry, A, B, C, D, therefore my vertices are 4, but my edge will be less 1. There's 3, only 1, 2, 3. Okay, so in other words, that means if I want to, let's say I have this directed graph. If I want to from A to go to D, I have only one root. I cannot have 2 roots. If I have 2 roots, that is not a tree, right? So that's what you said, what in layman say, huh? So this one, if I have 4 vertices, I can also draw like this. Okay, so I can draw like this also can. So this is A, this is B, C, and D. So you can see there are 4 vertices connected through C, but if I want to go to B to D, I have B, C, D. I cannot go to, I have one root only. All right. All right. Okay, so we can come to a conclusion that if it is a tree, the number of vertices must be more 1 than number of edges, or the number of edges will be less 1 from the number of vertices. Okay, so we have to follow this condition, the 3 condition, to determine whether a given graph is a tree or not, right? So let's see example 11. So example 11, I gave you A, B, C, D, E, F, G. There are 7. So A, B, C, D is from your textbook. Okay, so you can check. So you can see here, A, is it a tree? Okay, so it's very simple. You look at it. Is this is this there's a multiple or loop or not? This condition number 2. Right? You see condition number 1 first. Sorry, number 1. Okay, so it fulfill condition number 1, but it doesn't fulfill the condition number 2, because P, right, is connected, right? Is connected. You see all vertices are connected. At each pair is only connected only one edge, right? So, all right, so this one is connected. Okay, of course, this one fulfill number 2, but number 3, C, it doesn't fulfill, right? So you can see here, okay, a number of vertices, 1, 2, 3, 4, 5, 6. So number of vertices is 6, but the number of edges is 1, 2, 3, 4, 5. Sorry, 2, 4, 5, 6, 7. Okay, so this condition number 3 is condition number C, number 3 or C lah. C is not fulfilled, right? Because the number of edges is more than the number of vertices. So that is your conclusion. And then the other one is in the textbook, they say each pair of vertices can be connected in various ways. So meaning that just now I already said, okay, if I want to go to P to S, I have only one root. I cannot have 2 roots. So you see here, P to S, right? P to S, I have P, U, U, T. I have the other roots. So this is the other way to determine whether a given graph is a tree or not, right? Beside the three conditions. Okay, let's see B. B, okay, you can see B. If I want to P go to S, so I have one root only. And then each point is connected to another point with one edge. This one also one edge, one edge, one edge, one edge, right? So this one is a tree, right? So, and then we also can say that the vertices is 1, 2, 3, 4, 5, 6. Okay, so vertices are 6, and the number of edge is 1, 2, 3, 4, 5, right? So it fulfills A, B, and C. Okay, so let's go to C. Okay, C, is it a tree? So the first thing you see, any loop or not? No. So this is a simple graph. Then each point, each pairs of vertices only connected with one vertices. Okay, so if A got multiple edges, then of course B is wrong already, right? So because you already, if got A is multiple edges or loop, that means the vertices have connected, is not connected only one edge but two, more than two. Okay, so you can check the third one, the condition, or you can check using my checklist just now. I want to go from U to S. I have only one root. I cannot go U to S directly. Okay, so U. Okay, let's check the third condition. All right, so number of vertices 1, 2, 3, 4, 5, 6. Okay, 1, 2, 3, 4, 5, 6, correct. And then the number of edges 1, 2, 3, 4, 5. Okay, so this is a tree. This this is not a tree. This is a tree. This is a tree, right? Okay, justify your answer. So you explain like that. Okay, and each pair of vertices is connected with only one edge. Okay, now we go to D. Okay, D, is it a simple graph? Correct, right? Simple graph. So A, fulfill. B also fulfill. Let's check C. C, okay, C 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So number of vertices is 6. Number of edges 1, 2, 3, 1, 2, 3, 4. Okay, so C did not fulfill C, because the number of edges must be less one only, but this one is 4. That means R and T is isolated from PQS. So this is also not a, this is also can justify your answer, whether this is a tree or not. So remember, a tree must connect all the points given in the graph, right? Okay, so this is the textbook example. All right, so you can go through the textbook there. And this one is not a tree. Why not a tree? Because the number of edges and the vertices are not less than 1, and then vertex T and R are not connected to other vertices or isolated. Okay, so next one, E. Okay, E. Right, so we do the checking A, B, C. So A, okay, A. If A is not fulfilled, then you don't need to go to B. Therefore, there's a loop, right? So this, okay, the first one already, this is a loop, then it is not a tree. Okay, then we go to F. F, all right, let's check F. Right, F. A is a simple graph. Simple graph. B, each pair has one edge. Okay, correct. BT, although its V is connected to all the vertices except itself. Okay. C, all right, C, let's check the vertices. 1, 2, 3, 4, 5, 6, 7. number of age. Okay, number of age. 1, 2, 3, 4, 5, 6. So it fulfills C also. And then you can use my other method, that is I want to go P to R. Okay, so P to V, V to R. All right, so if I want to go to P to T, I have only one route, that is P to V, V to T. All right, so this is F. All right, so F fulfill all the three conditions. Okay, let's go to G. So therefore, remember this is a tree. We go to G now. G. Is this a tree? All right. A. Yes. Simple graph. B. Each pair only connected with one edge. Okay. Each pair is connected with one edge. Sorry, one. All right. And then C. All right, so let's see, let's check the vertices, the number of vertices. 1, 2, 3, 1, 2, 3, 4, 5. Number of edge, 1, 2, 3, 4, correct. All right, so this is also a 3. Okay, but here is a bit confusing. That's why when just now, beginning of the lesson, I told you when you draw a graph, you use a pencil to draw and then avoid overlapping. So here is a bit confusing that U and S overlap P and R, but there is no vertices here. So we consider that U and S doesn't cross each other. Okay, so therefore this is a 3 also. Okay, so I deliberately put this example just to show you how confusing your graph can be if you drew a network graph with overlapping. The edge is overlapping each other. Okay, so if you cannot avoid, then what to do? But if you can avoid, that means after you drew the first draft, your network has maybe has two or three edges overlapping each other, then you can redraw it again, right? All right. Then we go to example 12. Okay. Draw a tree based on the given information. So to be safe, all right, to be safe, okay, 6 vertices, we just draw 6 points like this to be safe. 1, 2, 3, 4, 5, 6. So you just connect like this. Okay. That is first option. My first option. The second one will be using this one, F. All right, that means I have 1 point in the middle, then it connected to others, 1, 2, 3, 4, and 5. So it's like this. Okay, so this is called, there's a name for it lah. So I don't want to discuss about the name, but this is a tree lah. So add vertices, you can try by yourself. So to be safe, you just draw like this, the first one. The second one, it will be 1 in the middle, then it will spread like this. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Okay, never mind, 6, 7. So you drew like this. This is also a 3. So 9 vertices, you can try by yourself. I think you know how to do. So this one is 1, 2, 3, 4, 5, 6, 7. So you can see 1, 2, 3, 4, 5, 6, 7, 8. So vertices. So you just count how many 7 edges. So you drew, then you get the answer. So this one, you can try by yourself. To be safe, you just draw 9 edges, then you will get a correct answer. Okay. Now we go to example 13. Okay, given you this diagram, so you can say that, of course, when you see the first, see this question, you know that this vertices, this graph is not a tree. It's by itself. So that's why the question said draw 2 tree based, trees based on the given graph. Okay, so that means we have to connect each of the point, right? Each of the point with only one edge. So very simple. Okay, the first one to be safe. 1, 2, 3, 4. Okay, so we have like this. 1, 2, 3, 4. Right. 2, 3, 4. Why only 4? There are 5 vertices only, right? So there are 5 vertices. So remember, there are 5. That means your tree must have only 4. That's why 1, 2, 3, 4. So the other one, how can it be? All right. So the other one will be using this one. Okay. Or just now where I drew, like this also. Okay. Right. 1, 2, 3, 4. Therefore, there's one in the middle as the connector for the rest of the place. Okay. So you can imagine this is, let's say this is our Malaysia. Okay. Or our, in Kuching or in Sarawak. So you want to fly from Kuching to other, let's say you from Kuala Lumpur, okay, or West Malaysia. You want to go to, let's say Miri. No lah, Miri. Let's say I want to go to where? Bintulu. Okay, Kapit. Not Marudi, I think got. Okay, so I want to go this place without using land transport. I want to use aeroplane. So you can imagine here, this is Kuching, right? Kuching. Then from Kuching, you can go to Kapit, a very small airport. Then you can go to Sri Aman. There's one airport, very small one. And then also other place. This is Limbang and Baram, let's say lah. So I'm not sure. So you can see this is also a tree. Okay. All right. Now we go to B. You see B here. How to draw a B with a tree, right? So in your textbook, it's very simple. So it's 1, 2, and then in the middle, and then go here and here. All right. So first thing, there's how many vertices? So 1, 2, 3, 4, 5, 6. So number of edges, 5. So 1, 2, 3, 4, 5. Okay, correct. Okay, so each pair only connected with one edge. All right, and then I want to go from this point to this point, so I need to go on passing to these 2 points. I have no other routes. Okay, so what else here? From beside this, okay, so in your textbook, it will show you a very conventional way. There is 1, 2. Okay, so this one is a bit confusing. The book answer is like this. Okay, like this, right? So it passed through this. So I don't agree with this this answer. Okay, so you can find other alternative. That means I can start here, right? So I can use other alternative way. So I go 1, 2 in the middle, then I go down, then go up here, and then go here. So I throw away. That means I use this route 1, 2, 3, 4, 5. Or you can use this also can. Okay, if I go use this, go up here, then go up here, here. So there are many trees around. Okay, so and then we go to the next one. Okay, so this one I think you can try by yourself. So the basic one is to be safe. All right, so okay. Okay, so we have only one like this. Okay, so this is the only one, I think. Any more? I think of. Okay, so there's one more. Okay, you can go here, up, down, here. Okay, that means I have one more going here, up, then go here, then go here, right? So it connected to all the vertices, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, and then there are 5 edges, 1, 2, 3, 4, 5. Okay, this one also same. 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, and then there are 5 edges, 1, 2, 3, 4, 5, right? So number of vertices 6, number of edges 5. Okay, all right. Okay, this one. The following diagram shows an undirected weighted graph. Draw a tree with a minimum total weight. Okay, so minimum total weight. So first thing, right? First thing we have to find out how many unnecessary edge just here. So there are how many points or how many vertices? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, right? Okay, sorry. So there are 5 edges, 5 vertices, and edge should be 4. But here you can see 1, 2, 3, 4, 5, 6, 7. So there are 7, so you have to minus 3. Okay, minus 3 edges that are not a minimum weight. Okay, so here let's check which one we throw it away first. So you see here there are 25 here, 20, so you can throw it away. All right, and then one more, you throw it a 19. So let's see what we get. Okay, so you get P, Q, okay. So here P, here is Q, here is T, here is R, here is S. So I have this. But this is not a tree, yeah? This is not a tree. Because P is not connected to T or Q. So what we do, okay, so we throw it these two away. So we have to connect this. So we have to throw one of it here. So that means I have to throw one of the line here. Okay. So I throw away which one? Okay, let's check. So I need to connect P to T with the shortest. No, I mean P and T, right? P to T or P to Q. So P to T and P to Q, this one 25, this one is 19. So of course we take the 19, right? And then Q to T, you have only one edge. Okay, one edge. And then now we have to decide. Okay, T to S, of course, there is only one root. There's 14. Then therefore R and S and R and T. So we have to decide one of the edges, right? So that means you look at it, 12 and 17. Of course, we throw the 17 away. So we choose the minimum weightage. Okay, so therefore our tree will be looking like this, right? Looking like this. So therefore our minimum total weight here, okay, our total weight will be 10, 12, 14, and 19, right? 10 plus 12 plus 14 and plus 19. So this is 55 lah. Okay, so let's check. All right, so B is not the total weight. So we want to find the minimum. We can assume this is a minimum total weight also. Okay, so let's check. Number of vertices. So 1, 2, 0 to 7, therefore is 8. So how many edge I need? I need 7. Okay, so I need 7. So I need to throw away all the big number. All right, the big number. So I throw away. Okay, so I throw away this. Okay, let's use another color. 5, 4, 6, 2, 5, 4, 5, 4. Okay, then 6, 3, and then 5, 4. So I need 7, right? So let's check. 1, 2, 3, 4, 5, 6, 7, 8, 9. So now this one I throw it away already. So this I must connect it to this is between, right? So I must connect it to, I throw it the 3.5 away. Right now is 0 to 2, 3 only one path, 0, 0.13 one path, okay, and 3.1, 4, 7. Okay, so this one I don't need. Throw it away also. Therefore, I have 1, 2, 3, 4, 5. So if I connect to this, right? So that means 4, 3 here, useless, right? I cannot use 4, 3. If I use 4, 3, that means if I start from 0, 2, 3, I go here straight away 5, 6, right? 5, 6. Then I will use the not a minimum weight already. Maybe this is maximum already. So 62, 0.62, 0.63 is maximum weight, is bigger weight. So I cannot use 62 and 63, right? So 4, 3, I have to sacrifice. Therefore, all right, so my roots will be 0, we go to 2, and then we go to 3, then we go to 7, then we go to 1, then we go to 4. Then from 4, we have to choose whether to 62. Okay, so 62. So we go here, and then number 4, this one 5, this one 6. So we are using this root 0.37, 0.54, this one 0.3, 0.31, 0.13, 0.31, and 0.14. Okay, so you can try other root, right? Okay, so let's check whether our chosen root is fulfilling NV is 8 and NE is 7 or not. Okay, so you can see quite clear. It's 1, 2, 3, 4, 5, 6, 7, 8, 8 vertices, edges 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. Correct. Right? Then we can check whether this is minimum or not. Of course, there are many other roots here that you can connect 0 to 6. All the points are connected with edges. But we want a minimum one, right? Minimum total weight. So we assume this is weight, gram, right? So let's check. Okay, 0.14 plus 0.31. So you have 5, 4. Then you have 0.3, 0.75, and then you plus 0.13. So you have 8, 8. Okay, and then 0.31. Okay, so you have 1.19. Then we plus 0.54. So here's 3, here's 7, 1.73. Then you plus 0.37. So you get 2.10 gram. Okay, so there are another root or not. Okay, let's say I want to take 0.43. I don't want to avoid this. So I have to go 0.37. All right, so I have to go this way. All right, so I use yellow. Okay, so I go here, then I must go here, right? So I go here, then here, and then here, and then here, stop here. So you can see the roots will be, this is 47, this is 43. So you can add up this, whether it is more than 2.10 or not, okay? All right, so let's check. So here, there's an alternative way. Okay, let's check the 0.14 plus. Okay, so from here, huh? Okay, never mind. So we start here, 0.37 plus 0.43. So 0.8. So 0.8 plus 0.31, 1.11. Then you plus 0.14. Then plus 0.47. Then you plus 0.31. Then you plus one more, 0.30. Okay, 2.33, so it's more than 2.10. Okay, so you can see here. I check again. 1, 6, 5, 3. Okay, you can use 6, 5, 3, 2, 0, 7, 1, 4. All right, so that mean here correct. And then 0.31 here, correct. Go down, go here, up, down. Okay, you cannot go to 0.13 anymore. So therefore, the best root is, the best root will be 0 to 2, 2 to 3, 3 to 7, 7 to 1, and then 1 to 4, 4 to 5, 5 to 6. Okay, this is the best root. Okay, so this is best root. Right, so do the exercise on 5.1c, page 142. All right.